Hi again. Please move forward to the Learning Outcome 4.5 sheet. Now we're going to learn more about the normal distribution by converting normal distributions to the standard normal. When we talk about the normal distribution, because it will look different depending on what the mean and the standard deviation of the distribution are, there's technically unlimited combinations and unlimited numbers of normal distributions. The mean controls where the middle of the distribution is, and the standard deviation controls how flat or how peaked the distribution is. To simplify calculations, instead of looking at all the possible means and standard deviations available, we can use one special version of the normal distribution that we call the standard normal distribution. The definition of the standard normal distribution is that it's a regular normal distribution. So what I mean by that is it still has a bell-shaped curve, it's still symmetric, and it's still unimodal, but it has a mean of 0 and a standard deviation of 1. If we go back to the graphing calculator that we opened in the last example, if you move the mean of the distribution to 0 and the standard deviation s to 1, this is what we call the standard normal distribution that has mean of 0, so it's located right over where the x and y-axis both meet at 0, and a standard deviation of 1, which means that it's kind of in the middle. It's not super flat and it's not super peaked. It's right here. And that would be what's called the standard normal distribution. So why do we care about finding the standard normal distribution, the special normal distribution that has a mean of 0 and a standard deviation of 1? Well, really the reason is for comparison. You can compare normal distributions to each other, and you can also know if a value from the normal distribution is considered regular, typical, or an outlier by looking at the normal distribution. When we convert a normal distribution into a standard normal distribution with a mean of 0 and a standard deviation of 1, we do that by calculating z-scores. Z-scores are a quantity that tell you how many standard deviations away from the mean you are. How you find them is you take any value x that you're interested from the distribution and you minus the mean. By minusing the mean, no matter what value of x you were at before, let's say you're at 23, if you do 23 minus 23, you'd be back at 0. So basically, what happens is if you subtract the mean from every single value in the normal distribution, you'd be centering it at 0. So it's converting it to the standard normal. Then to deal with the spread, you take the value and not only subtract the mean, but you divide by the standard deviation. Any number divided by itself is 1. So if you think about dividing by that standard deviation, it's giving you the standard deviation of the standard normal distribution of 1. Let's say the standard deviation was 5 before. 5 divided by 5 is 1, so you're converting it onto that standard normal distribution with a mean of 0 and a standard deviation of 1. Any positive number for a z-score will indicate the quantity is positive and above the mean, and any negative value for a z-score will indicate that it's a negative quality that was below the mean. The higher the score is for the z-score, the farther it is away from the mean, and it will get more and more unusual. So if a value is close to 0, the middle of the standard normal distribution, or the mean of the standard normal distribution, then it's not an irregular value. But if you get a value of 5 for a z-score, then that would be a lot more unusual because that means it's 5 standard deviations away from the mean. As we progress through this part of the lesson, I'll talk to you more about how the z-scores are related to outliers. Before we get there, let's just learn how to find the z-scores. So suppose you have a normally distributed variable with a mean of 5 and a standard deviation of 6. That's what this notation means. X is distributed as is what this little curve means. It's called a tilde. N means normal. 5 is the mean. 6 is the standard deviation. Again, that's explained in words here. This means that x is normally distributed with a mean of 5 and standard deviation of 6. If x is 17, what is the z-score and what does it mean? So you could actually type it in, like equals 17 minus 5, over 6, and that's technically the z-score formula. Instead, though, Excel does have a formula that does this work for you. It's called standardize. You put in the value of x, you put in the value of the mean, and you put in the value of the standard deviation. Then Excel does the subtraction and the division for you to calculate the z-score of 2. A positive value of 2 means that the value's 2 standard deviations away from the mean. When we talk about away, specifically, it's higher than the mean or above the mean because it's a positive number. Any positive number indicates the quantity is above the mean. So this value is 2 standard deviations above the mean. Again, it's above because it's positive. It's 2 standard deviations away because the actual value is 2. How this relates to allowing you to look for patterns in the data is we have a rule for the normal distribution called the empirical rule that you can use the z-scores even if normal distributions are measured in different units. Like in the last example, we saw normal distributions for height, for blood pressure, for test scores, for IQ scores, for, again, test scores is a common one, but they are measured in different units. So no matter what the different units they're measured in are, you can use standardizing and calculating the z-scores to compare the distributions, even if they're on completely different units originally. We know that for unimodal symmetric distributions, the mean, the median, and the mode will always be equal. And because of these specific patterns in the data, we have some other observations we can make as well. And this leads to what's called the empirical rule. The empirical rule states that for a symmetric and unimodal distribution, that's a normal distribution, then we know that 68% of the data will be located within 1 standard deviation of the mean. What does this actually mean? Well, if I were to draw out a picture, just going to draw my curve. Here we go. If I were to draw out a picture, the mean's in the middle for the symmetric unimodal distribution. If the standard deviation, you go 1 standard deviation less than, so the mean minus the size of the standard deviation, and the mean plus the size of the standard deviation, we can say that 68% of all your data will be in this range between those 2 points. 68% probability of being between 1 standard deviation lower and 1 standard deviation above. If you go instead to 2 standard deviations out, minus 2 standard deviations, and plus 2 standard deviations, so here and here, 95% of your data will be between these values. If you decide to go far out to 3 standard deviations, just going to switch this to red. Didn't switch when I tapped it the first time. There we go. So mean minus 3 and mean plus 3, between those two values, 99.7%, or there's a 99.7% probability of being 3 standard deviations either above or below the mean. So between these values here. 99.7% is almost 100% of the data. So our rule is that if you have any value with a z-score bigger than 3, we call it an outlier. So if the z-score is bigger than positive 3 or less than negative 3, we call it an outlier. That's because 99.7% of your data is supposed to be within the minus 3 and the plus 3. So if it's beyond that, it's only 0.3% chance of that happening. We'd consider it very unusual, which we call an outlier, a data point that does not match with the rest. We learned about this back when we talked about the Kentucky Derby data set, but now instead of just looking at a picture like a box plot to determine the outliers, we actually have a calculation that can show you if you have an outlier or not. So how can we use the empirical rule in calculations? Well, it's pretty simple. Here we have a normal distribution with a mean of 50 and a standard deviation of 6. If you want to find what score 68% of the data fall between, we know 68% of the data is within one standard deviation. So you take the mean minus the standard deviation and the mean plus the standard deviation. This means 68% probability of getting a score between 44 and 56 on the test, if this is test scores. What about 95% of the data? According to the rule, 95% should be within two standard deviations. What does that mean? It means you would take the mean and minus 2 times the standard deviation, and take the mean and do plus 2 times the standard deviation of 6. This means 95% of your students should score between 38 and 62 if this is a test. Then, for 99.7% of all the data, you take the mean and minus 3 times the standard deviation. You take the mean and add 3 times the standard deviation of 6. This means 99.7% of all students should score between a 32 and a 68 in points. Any values higher or lower than these are considered outliers because they would be beyond that Z-score of 3, or what is meant by 3 standard deviations below and 3 standard deviations above the mean. Another question is in the opposite direction. What value of X would have a Z-score of 1.5? So basically it's asking you what number would be 1.5 standard deviations away from the mean. Because this is a positive 1.5 Z-score, all that means is you take the mean and add 1.5 times the standard deviation. That would be a Z-score of 1.5. So a value of 59 would have a Z-score of 1.5. To test that that's true, you could use the standardized function and say, does the value 59 with a mean of 50 and a standard deviation of 6 come out to a Z-score of 1.5? And it does. So it shows you can go both directions, that the empirical rule and the Z-score formula are related, that the empirical rule just gives you specific percentages associated with how many standard deviations away you are from the mean, and they're also associated with Z-scores. 68% of the data is associated with a Z-score of -1 standard deviation and +1 standard deviation, so Z of 1. 95% is 2 standard deviations below and above, so it's associated with a Z-score of 2. And 99.7% of the data is associated with 3 standard deviations below and 3 standard deviations above, so it has a Z-score of 3. Beyond that is considered an outlier. I have a check for you to try out the formulas on your own here and interpret some Z-scores. So please pause the video, and then when you press play again, I'll show you the answer. So the systolic blood pressure given in millimeters of males has an approximately normal distribution with a mean of 125 and a standard deviation of 14. The blood pressures follow a normal distribution. We want to calculate the Z-scores for both 100 and 150 milliliters. So for 100, I would use standardized to calculate the Z-score. Score of 100, the mean is 125, the standard deviation is 14. Your Z-score should be negative 1.7857 approximately. For a blood pressure of 150, I'd use standardized with 150. The mean is still 125. The standard deviation is still 14. So I actually get the same number, just for X as 100, it's negative 1.78, and for X of 150, it's 1.78. Why do you get the same number? Well, it's because both are the same distance from 125. If 125 is in the middle, then 100 is 25 units below, and 150 is 25 units above. So that's why they come out as the same Z-score. The Z-score is about 1.78, So that's less than 95% of the data would be between these two scores. We don't know the exact number yet, but it's somewhere less than 95%. Another related question says, if a male friend of yours said he thought his systolic blood pressure was 2.5 standard deviations below the mean, but he thinks his blood pressure is between 150 and 100 and 150 milliliters, would you believe him? You won't have the exact same answer as me, but what I wrote is that his blood pressure is lower than 100 because we know 100 corresponds to a Z score of negative 1.78, which is below the mean. He says his blood pressure is 2.5 standard deviations below the mean. So this means if his blood pressure is negative 2.5 because it's below the mean, it is much less than 100 because 100 is only negative 1.78. To get a score of negative 2.5, you have to be even less than 100, somewhere out here, farther away from the mean. So he has not interpreted his blood pressure correctly. Another thing you could do is kind of do the backwards part like we did here to figure out what his blood pressure actually would be. If he thinks his blood pressure is about 2.5, you could take the mean of 125 and subtract, because he says it's below the mean, 2.5 times the standard deviation. So his blood pressure is probably only about 90, not 100. So as long as you had some kind of explanation that said that no, his blood pressure isn't between 100 and 150 with a score of 2.5 standard deviations below the mean, then you have answered the question correctly, as long as you have some explanation similar to this one. Okay, so Z scores and the empirical rule tell us how far different points are away from the middle. Z scores give us a way to compare distributions to each other so that we can say, like, if you get a score of higher than 3, it's an outlier, or less than 3, it's not an outlier. And the empirical rule gives you certain percentages associated with how far away the data is from the mean as well. We're going to build on this in the last part of the lesson for learning outcome 4. So please watch the next video for learning outcome 4.6 to keep learning more about the normal distribution.